Hi, my name is dr. Ahmath. In this video lecture, we are going to continue our discussions about vectors. In particular, we're going to discuss about algebraic operations over the vectors. Well, if you are given vectors, how to add them, how to subtract them, how to multiply them at constant, and how to find their lengths. Well, a vector is a mathematical quantity which has two attributes, essentially, as direction and magnitude. And in our previous lecture, we discussed how to do the operations or the vectors geometrically. Well, how to add the two vectors, subtract the vectors, and what does it mean multiplying a vector to a scalar. Well, in this lecture, we're going to discuss about the vectors algebraically. And algebraically, the vectors are going to be given as so-called two-tuple. So the two-tuple is the definition of something which is two numbers written inside a vector. So u1 and u2, which is written inside a bracket, is simply called as a two-tuple. So not any two numbers inside a bracket is called two-tuple. For example, 1, 2. For the two-tuple, the attributes coming first in the first position inside your brackets is different than the attributes coming in the second position conceptually. So that is why you can't really just make the equality sign for the 1 and 2 and 2 and 1. Even though the same numbers are participating there, they are different. So you can understand that 1 in the first position, you are given some category 1, category 1, and in the second position you are given category 2. For example, category 1 can be the currencies, category 2 can be some fruits, for example, and so on. So that is why if you are given one vector with the category 1 and category 2, and the second vector v1, let's say, with a category 1, let's say v, and category 2v, and if you would like to add them or subtract them, you can do the operations only with the same categories. For example, you can add the two vectors in the same categories. Again, the category 1 can be some supplies, home supplies, right, or the vegetables, and the category 2 can be the fruits. So you can add the categories, add the two vectors by the categories, okay, so by the positions. So this is what does it mean, the two tuples. So the two tuples are really useful in many areas, many scientific areas. In computer science, it is widely used in order to store the data. For example, if you would like to store the profit of your company by the months, you can just store this in the 12th tuple. So you're going to store this inside some brackets with the 12 numbers here. So the months 1, months 2, and so on, months 12. And by the category, by the concept, all of those numbers are going to be different conceptually. Well, if you are given these two vectors, u and v, as a two-tuple, how we are going to add them or how we are going to subtract them. So the way how to do is the following. So let's say you're given a u and v, and if you would like to add the u and v, so we are going to create again a vector. So if you're given two vectors which are in two-dimensional space, which are given with the two tuples, the addition is also going to be a vector in 2D with two tuples. You can't really just change the dimensionality of the vectors by just adding them or subtracting them. So the u1 plus u2, u1 plus v1, and the second component or the of the resulting vector is going to be u2 plus v2. Well, this is going to be the first operation. If you would like to subtract u minus v, you're going to do pretty much the same thing. So it's going to be u1 minus v1, u2 minus v2. This is going to be the second operation. And the third operation is if you would like to multiply u to some constant c, it is going to be c times the u1 and c times the u2. So this is going to be the third operation. There are three essentially important operations over the vectors algebraically. And let's assume that if you are given a vector u with the components 1 and 2, and vector v with the components -3 and 4, how to do this operation. So let's do this together. So the u plus v is going to be equal to 1 minus 3. Right, so I'm just going to add this one with this one, and 2 plus 4. And if I add them algebraically, it is going to be simply equal to -2 and 6. Very easy. So the u minus v is going to be pretty much in the same way. So 1 minus -3, 2 minus 4, well, that's going to be 4 and -2. So please know that it is going to be different than this vector, obviously. And if you would like to multiply the u to some constant 4, let's say, it is going to be 4 times the 1, which is the first component of this vector u, and 4 times the 2, which is the second component of this vector u. Well, that's going to be equal to 4 and 8. So, well, that's how we are going to do the operations with vectors algebraically. So let's do one more difficult problem. So let's say you were given u, so that's obviously u here, u vector with the components 1 and 2, and v vector with the components -3 and 4. We have to find 2u minus 3v. So first of all, I'm going to find the 2u. We have to find the sum of the components, right? So let's find first of all 2u. That's going to be 2 times the 1 and 2. I'm just going to multiply this constant to every component of this vector. That's going to be 2 and 4. So -3v, it's going to be -3 times the -3 and 4. Well, that's going to be 9 and -12. And now I have to add them. So 2, 4 plus 9 minus 12. It is going to be, now we're going to add these two vectors component-wise. That's going to be 11 and -8. Okay, so that's the new vector. So if you do these operations again, so it's really important. If you add the two vectors, or if you multiply a vector to constant, you can't really just change the dimensionality of the vector. So the vectors which are given with the two tuples are going to remain in the same dimensionality, are going to remain with the two tuples at the end. So now, if you need to find the sum of the components, you just need to add 11 with the -8. That's going to be sweet. So the sum of the components of the operations of these two vectors is going to be equal simply +3. So now let's discuss how we can find the lengths of the vector and derive the formula to do that. So let's say you are given a vector. So let's assume that both of the components of this vector are positive. It is an easy way to show the formula of the lengths of the vector. So let's say you're given this vector with the ending point u1 and u2. That's going to be my vector u. Well, in 2D, if you would like to find the lengths of this vector, you're going to find the lengths of the side of the triangle, which is obtained by Pythagoras theorem. So the height of this triangle is going to be equal to the y component of this point, which is u2, right? And the width of this triangle, it's going to be u1, which is the x component of this point. So this is the concept of the point. So if you would like to make a point with the coordinates, let's say 1 and 2, it means that you need to go in the x direction 1 unit and the y direction 2 units, right? So this is why we are going to have u1 as the width of this triangle and u2 as the height of this triangle. And if you remember the Pythagoras theorem, if you need to find the length of the u, we're going to denote this with these two vertical lines before and at the end of this vector, which we also call as the norm of the vector. It is different notation. So the length of the vector u is going to be equal to the square root of u1 in the square plus u2 in the square. Okay, again, I can't really just write u is equal to the square root of u1 in the square plus u2 in the square, because if you remember, u was a vector. It should come with the two tuple, right? You can write u is equal to 1 and 2, but you can't really write that u is equal to some number, because now we are going to obtain a number, a scalar, by doing this operation. So this operation, finding the length of the vector, is going to change the dimensionality of the vector. So if you add the vectors or subtract the vectors, or if you scale the vectors, you can't really just change the dimensionality of the vector. But if you find the length of the vector, it is always going to be a number, single number. No matter what is the dimensionality of your vector. Well, we can do a small example. So let's say you are given the u so let's do this for this example was the components 1 and 2, and if you need to find the length of the u, I'm going to denote this two vertical lines before it. And at the end of the vector u is going to be equal to the square root of 1 in the square plus 2 in the square, then taking the square root. Well, 1 plus 2 in the square, which is 4. 1 plus 4 is equal to the 5. That's going to be square root of 5. Well, if you are given the vector u, or vector v, let's say, vector v was the components minus 2 and 3, then the norm of the v is going to be equal to the square root of minus 2 in the square, which is 4, plus 3 in the square, which is 9. That's going to be square root of 13. Again, you can see here that the norm of the vector never can be a negative number. It can be 0 if and only if your vector is a 0 vector. If all of the components of your vector are zeros, then the length of this vector is equal to the 0, and that's the only case. Okay, so now we need to talk about one of the really important type of the vectors, which is called a unit vector. It is very useful for us to make our computations much more efficient and easier. A vector with the length 1 is called a unit vector. Well, I know that most of you know the standard unit vectors like the I or J. So they are unit vectors. I has the component 1 and 0, and J has the component 0 and 1 and 2D, and their length is equal to 1. We can check this out. For example, the length of the I is going to be equal to 1 in the square plus 0 in the square. From the square root, that's going to be 1. And the norm of the j, the length of the j, is also going to be equal to the square root of 0 in the square plus 1 in the square. That's also equal to the 1. Well, they are unit vectors, but they are not the unique unit vectors. So they are not the only unit vectors. There are many other unit vectors. So essentially, there are infinitely many unit vectors. So I can explain you this in this way. Let's say you've got the rectangular coordinate system, and let's say I've got the unit circle, a circle with a radius 1. So any vector which is pointing out to the circle, a unit circle, this vector or this vector, all of them are the unit vectors. So this vector with the components minus 1 and 0 is also a unit vector. So there are infinitely many unit vectors. So I can show you a couple of more examples. So let's say u was the components 3 over 5 and 4 over 5 is also a unit vector, because if you find the norm of this vector v, it's going to be equal to the 1. So the only condition for calling the vector to be unit is its length should be equal to the 1. Now, most of the time, if you're given a vector u, which is not unit, how to find a vector which is unit in the same direction of this vector v, or vector u? That's a really interesting question, and let's try to do this together. So let's say you've got, again, the coordinate system. So that's going to be y, and that's going to be x. So let's say I've got this vector 2 and 2, right? And this vector u was the components 2 and 2. I need to find a vector, this vector, smaller vector, obviously, because the length of the vector u is more than 1, right? The smaller vector, so that it's going to be unit. So I need to find this vector. So let's say I need to find a v vector, so which is going to be a unit vector in the same direction as the u. So if you remember our previous lecture, we discussed about the geometric operations. So you need to do some operation over u in order to obtain the v, so that you don't change the direction of this vector, but you change the length of the vector only. And if you remember, this operation which changes the vector without changing its direction is simply the scaling the vector. You have to multiply the vector to some constant. So this vector v actually, so this vector v, again, so let me draw this one more time. U was the components t and t. V is here. And the vector v can be obtained by just multiplying this vector u to some constant c. So let's say some constant c times the u, right? And the only thing is you have to find a c. So the way how to find a c is to take the norm from both of the sides. I'm going to take the norm here, then take the norm here. So this constant is going to be out from the norm. So on the left hand side I've got the norm of the v, on the right hand side I've got the c times the norm of the u. So the norm of the v is equal to the 1. That's the definition of the v. So any unit vector is the vector with length 1, right? And the c from here is going to be equal to the 1 divided to the norm of the u. And if you need to find a v actually, so I'm just going to use this equation, the first equation. It is going to be u divided to, instead of c, I'm just going to write down 1 divided to the norm of the u times the u. Okay, so this is what I have to do. So essentially, it appears I just need to divide the length of the vector to itself in order to find the unit vector in the same direction. So the norm of this vector u actually is equal to the square root of 2 in the square plus 2 in the square. That's going to be 4 plus 4, square root of 8, or essentially 2 times the square root of 2, right? And I have to just divide 2 and 2 to the 2 divided to the square root of 2. And if I divide this, I have to divide every term of the vector, every component of the vector to this constant. It's going to be 1 divided to the square root of 2 and 1 divided to the square root of 2. Well, that's vector v, which is in the same direction as the u, but with the length to be equal to 1. So these are the algebraic operations over the vectors. They are really important. Thank you very much for your attention, and I hope that this was helpful.